Our next speaker is coming all the way from Columbus, 2.5 hours drive to the south. Brian Guilfoos is a senior HPC client service manager from OSC, and he's going to talk about what OSC can offer to us as researchers at CASE, especially the new resource that they're going to open up pretty soon. Okay, thanks.
Thank you. So I'm very grateful that I was invited to come and speak to you today. Hopefully you guys can hear me okay. So I've only got about 15 minutes though, so I'm going to be somewhat quick. I wanted to talk mostly about our new cluster, but I want to talk also a little bit about some of the services we provide and echo some of the things you've already heard today. The first thing I want to echo is what Mike just said about it's the people that make these resources useful, right? You can stand up a bunch of hardware, but to really make it useful, you need to build software and applications that work. You need to have people to help the researchers become productive on those systems. And that's really what my group does at OSC, is we're that point of contact for folks who want to use us. And we kind of sit between the resources you have here at CASE and then maybe stepping up to the Exceed level. We're kind of a layer between as a statewide resource. So I'll talk a little bit about our impact to help kind of contextualize where we fit into the picture. Oh, good, that is nice, easily read. So 25 different Ohio universities used us in 2015, 33 different companies, almost 1,300 different users ran jobs, 124 people attended training opportunities, 451 different awards. We use a grant system as well, like Exceed does. 459 different research projects and 19 different academic courses used us to support their teaching. And some numbers I just got this morning, 108 PhDs were granted to our users last year and 86 master's degrees. So again, it's the people, right? It's the number of people that we're helping to educate and the science that's being done that's the more interesting stuff. Then the second line, which is our production capacity, 161 million core hours, 4 million jobs, almost a petabyte of data, and about 99.7% uptime. So new faculty, 116 new faculty from around the state of Ohio. You can kind of see the diversity in institutions there. We've got the big R1s like CASE and UC and OSU, but places like Worcester and Kenyon and Walsh as well that are able to take advantage of the services we provide. The 459 active awards also spread around the state. CASE is kind of in the second tier there with the 11 to 20 group behind OSU and UC. And I think a large part of that is the local resource that you have here serves a large number of your needs. And then the 19 course awards. And that's actually something that I think is one of the lesser well-known services we provide, is we provide accounts to students in undergraduate or graduate classrooms to do computing as well. So, and there's no real proposal mechanism for this. We just ask us for the accounts and give us a syllabus, and we'll take your class roster and generate accounts for everybody. And then who's using us? There's you'll probably notice that doesn't add up to 100%. We've removed industrial or people labeled other or unknown, but it's mostly mathematical and physical sciences. Those are the large users. Chemistry, computational chemistry is a big user of our services. So Owens is our new cluster that we're installing this year, along with a bunch of other services as well. We're basically gutting our center and building a whole new center this year. So we're replacing all three of our storage services, Home Directory, Project, and Scratch. We expect to have all of those deployed this June. The hardware is there and being configured and tested now. We have to do some data center facilities improvements at the State of Ohio Computing Center. We went through the controlling board April 4th, and that work is scheduled to be completed, I think, it's actually not August now, I think it's actually September. In the supercomputer, we actually have delivery of the new hardware. These numbers have already changed since I made the slide yesterday. Delivery is now early June. Limited production is still August 15th, and full production is now November 1st. So that's actually an improvement. But these numbers are still a little bit in flux because of the difficulties of facilities improvements and things like that. So the storage upgrades that we're going to deploy this year, we're going from 300 terabytes to 900 terabytes for home directories. And there's a performance improvement with that. That's going to be a NetApp appliance that we're going to be installing. Project storage, we're going from 1.1 petabytes to 3.4 with a massive improvement in performance there, the 40 to 50 gigabytes per second range. Global Scratch, we're going from about 570 terabytes to a petabyte. That's also going to see a performance improvement over what we have in place today. And then tape storage, we're going from 2 terabytes to 5.5 with planned expansion to 10 terabytes. And for clusters, so we operate 2 currently, Oakley and Ruby. If you're a user on our systems now, you'll know that both of those are pretty full. Thankfully, with Owens coming online later this year, that's going to help us tremendously. So the numbers we see here for theoretical performance, Ruby and Oakley both include accelerators in those numbers. The Owens number is just CPU. So we're going to roughly triple our compute just by adding a bunch of CPUs. And I'll talk in another slide in a moment about what those CPUs look like and what the GPU plans are for Owens as well, because we do have some plans there. So we're adding 824 nodes and this is a Dell machine, by the way, 824 nodes, over 23,000 cores, and new EDR InfiniBand. So these are the 3 types of nodes that we're putting into Owens. Our dense compute, so 648 Dell PowerEdge nodes with Broadwell. There are 2 processors, 14 cores per processor, so 28 cores per node. Broadwell chips there, and 128 gigs of RAM on those nodes. We're going to have 160 GPU-ready nodes. The plan is to put Pascal accelerators in there later this year or early next year, depending on when we can get our hands on those. Again, the same Broadwell processors that we have in the dense compute nodes, and the same amount of memory. And then 16 analytics nodes. So these are going to be 1.5 terabytes of RAM in these machines. And slightly older Haswell processors. This is because it's hard to get motherboards for the Broadwells that can support this much memory. And then 8 of those 16 nodes are also going to have a large amount of local scratch space on those nodes, 24 2 terabyte drives in each of those. So we actually have an early user program for this system as well. We're accepting applications until May 20th. We have a couple of folks from Case who have already applied. The GPUs are not going to be available, right? We don't have those today, or we won't have those when the system's delivered in a couple of weeks. But we are looking for a diverse user base. We'd like to touch users from a variety of disciplines so that we can make sure that we're just kind of stressing the hardware in different ways. Preferably folks who are experienced in research computing. If you've never used OSC, you're probably not a good candidate for this because you're going to have to do a little bit of your own heavy lifting to get things working. There may be outages, so you need to be able to be tolerant to that and willing to work with us to identify problems that you come across. But the URL is there if you're interested. That took way less time than I expected for me to cover. So does anybody have any questions about the new system or anything about OSC in general? Yeah.
So how are you guys funded?
That's a great question. So we are funded by the state of Ohio. We are actually, OSU is our fiscal agent. So this kind of confuses people sometimes. I'm an OSU employee, but we are not an Ohio State University agency. We're under the Department of Higher Education. So we're funded directly by the state of Ohio. We show up on the state budget as a line item. They provide they provide all of our capital expenses and most of our operating. We do recover, and I didn't have a services slide in here, which is unfortunate. We do recover a portion of our operating costs via fee services. So most of these services that we provide to users are fully subsidized by the state. There are some services that we can offer for cost. So we do sell cycles to commercial clients. If you wanted to lease nodes on our system and have preferential access to those, our condo program, that's available as well. But the bulk of our services are fully subsidized by the state. Yes, please.
Could you speak just a little bit more to the analytics-focused
compute nodes and specifically comment on these 8 nodes that have the extended disk space? What kind of space that? I mean, is it SSDs or traditional, and why?
So, yeah, so currently we have, each of our existing clusters has one data analytics node, or we just call them huge memory nodes right now, right? So we're seeing increased demand for those resources, so we wanted to kind of provide some of these large memory nodes for people who are doing the statistical work that they can't load into memory, for example. So we've added these 16 on this particular cluster. That is a great question about the disk. I'm not sure which it is, whether we got SSDs in there or not. I know we are doing some work with SSDs in this cluster. I think that's primarily with write caching for project space. So I'm not sure off the top of my head. I'd have to go back and talk to our architect or look at the quote from Dell to verify.
So you do also then just carry these as more capable for analytics, but still designed from a general use perspective.
Well,
I take it. Or can you guide us through a little bit more of your thinking?
Yeah.
There?
So yes and no. We kind of we schedule pretty much everything on our systems through. So I guess my hesitation here is that we look at, from a scheduling perspective, we look at everything as HPC workload. So it all goes into the same queue, whether you're doing high throughput computing or high performance computing or data analytics work. However, we've got this scheduler set up for the other nodes that we already have to treat them as a distinct resource. So those, and it's easy to do because the core count is wildly different. I mean, they look so different from the other nodes that they're only used for kind of analytics work. So if normal, like for example, normal HPC workload won't end up, because there's a limited number of them, it won't end up taking those away and kind of restricting access to those. So scheduling for those would still go through an HPC scheduler, through Torque and Moab. It would just be done by putting a specific request for, I need the big memory node or the huge memory node.
I have one more question.
Sure.
But if someone else has a question, I would defer. I will go ahead. In the context of supporting coursework,
Yeah.
how do you manage the kind of usage of users in that context somewhat separately from the more production-oriented use? What I'm thinking of are students tend to flail around a bit as they're
Yeah.
exploring,
Yes.
and so that's where I'm coming from.
Yeah, so we don't currently treat them too much differently from the rest of our users. And we're able to get away with that because the volume is relatively small. And typically the things they do are fairly small still, even though there is some flailing around. It is a good way to put it because we have seen that. So we typically, the way that we do this is we'll give a 5,000 core hour allocation to the classroom project, which is typically way more than enough for any sort of classroom use. We have seen that exhausted before, sometimes legitimately, sometimes due to user error. So students are flailing around. So we can go in and we can work with the professors in those cases to kind of help control things if necessary. And one thing I should mention too, and this is actually a good thing to note since we are so full right now, is reservations for classroom. I mean, obviously lab times, for example, it is a terrible waste of lab time to be sitting in a queue. So we can generate reservations to support lab activities and things like that, so that there's good turnaround time when the TAs and instructors are available to help answer questions.
Thanks very much.
You're welcome. Any other questions? Great. Thank you.